2006. Question 4b. A smooth wedge of mass 3m and a slope alpha rests on a smooth horizontal surface. A particle of mass m is placed on the smooth inclined face of the wedge and is released from rest. A horizontal force F is applied to the wedge to keep it from moving. Show in separate diagrams the forces acting on the wedge and the particle. Okay, let's have a look at the particle M. That's the reaction, normal reaction here between the particle and the wedge. So coming down this way, we're going to have its mass times gravity, mg. We have this angle alpha in here, or the slope that they were telling us. The opposite direction to this, to or. We're going to have A in here. We're going to have mg cos A, opposing or, and parallel to the slope, we are going to have mg sin A. And my m in here. And it's going to come down the slope, so my acceleration in this direction, no mu in this case. So let's look at the wedge. It's 3m, so we have 3mg. We call the reaction between the wedge and the horizontal surface S. We have the or going on in this direction. And I probably should make that a little bit bigger. But coming down in this direction, I'll move the 3mg's arrow a little bit over to here. So down in this direction, the angle A inside it. This A in here, so this is going to be or cos A, it's adjacent to A. So what else have we got going on? We have the force coming in this direction, stopping it moving. So let's go to my blue equations first. We're going to have or is equal to mg cos alpha. So that's perpendicular to the plane and parallel to the plane. We have this mg sin alpha along here, making it thicker. Mg sin alpha, nothing opposing it, so we have mg sin alpha along the plane, the direction of A. It's going to be equal to ma, so just ma. Cross out your m's, so we're going to get acceleration. It's just going to be g sin alpha. So let's have a look at our reds. So we take S first up in this direction, because it obviously can't go through the ground. So S is going to be equal to the 3mg plus the or cos alpha. We have or from up here. Will this help us get into the question? S is equal to 3mg plus mg cos alpha by cos alpha. So S will be 3mg by mg cos squared alpha. And I can factor out mg to get 3 plus cos squared alpha. Actually, that's what they're looking for here. I didn't read the question first, which I probably should have. But that is the reaction here. And if the speed of the particle after 1 second is 4.9 meters a second, find the value of alpha. So it starts from rest, and t is equal to 1, v is equal to 4.9. So v is equal to u plus at, and we have a, don't we, here, g sin alpha. So v is equal to u plus at. 4.9 is equal to 0, and a is minus g sin alpha times t. So t is equal to 4.9 over g sine alpha. Well, we'll change that to 9.8. So that's the equivalent of 1 over 2. And we know t is 1, so 1 is equal to 1 over 2 sine alpha. So you're going to get sine alpha equal to a half. Just double check that. You're going to get 2 sine alpha is equal to 1. Sine alpha is equal to 1 over 2. So that will give alpha equal to 30 degrees. So that works out nice and easily. No decimals involved.